Hello everyone, so my name is Fabiana and right now I'm going to try to explain you of how we find some integration problem. So here's what we get. The integration calculation by PhotoMath. So PhotoMath is basically an app created by Google that will help you solve your math problem. So right now I'm going to explain you of how to find this. I'm sorry, let me turn on the highlight. So here I'm going to explain you how we get this equation so we can get this answer. So if you were using PhotoMath, somehow you'll get really confused of how we get this step to this step and suddenly we get this. So here's I'm gonna try to explain it to you. So the first step. How we get this, the integral of 3 over x minus 1 dx is equal to 3 times integral of 1 over x squared minus 1 dx. So here's why. We're using something called integration properties, which is integral of a times fx dx is equal to a times integral fx dx. So we get 3 as a, we change the value of 3 here as a, so we get 3 as a, and x squared minus 1 is equal to fx. So here we get integral of 3 over x minus 1 dx is equal to 3, we take the 3 out, times integral of 1 over 3 squared minus 1 dx. So here's how you get the first step. Next, we move into the second step. So 3 times integral of 1 over x squared minus 1 dx. We get this answer. Why? So here's why. First, you have to change 1 into a, so we get 1 is equal to a, or a is equal to 1, which is the same. So integral of 1 over x squared minus a dx is equal to 1 over x squared minus a squared dx. Why we changed a into a squared? Because basically a is equal to 1, so 1 raised to the power of 2 is basically just equal to 1. Unless you put some parentheses in it, it will be different. So here we move to the next step. I will need a pen to show you this. So integral of 1 over x squared minus x squared dx is equal to integral of 1 over x plus a times x minus a dx. Why? So here we're using something called algebra formula called the factoring formula, which is how we get this x to the power of 2 minus a to the power of 2 is equal to this x plus a times x minus a. Let me point it out. And move to the next step. 1 over x plus a times 1 times x minus a, is equal to a over x plus a times b over x minus a. How we changed 1 into a and b. So it's called partial factoring decomposition, where here we're trying to find the product of one of. So why this is how we're using a and b, because we don't know the value, so we're just using a and b, and then we will add both sides, so we will get 1. So 1 over x plus a times x minus a is equal to a times x minus a plus b x times plus b times x minus plus a over x times a, x plus a times x minus a. So how we get this form? From this. So this is just some basic fraction rule that if you wanted to add some fraction, you have to make the denominators the same. So we just multiply it. So x plus a times x minus a and we divide this into this. So if you divide this equation into this equation, the plus a will be cancelled out. And if you divide this equation into this equation, the minus a will be cancelled out. So here we only have a times x minus a plus b times x plus a over the denominator, which is x plus a times x minus a. So the next step is that we wanted to get rid of the denominator. So what we do, we just multiply it by x plus a, x minus a, so it will cancel out. This both side will cancel out. So here we have this a times x minus a plus b times x plus a is equal to 1. So we're using the factor formula again. So we have x, we take out the x from this and this, so we have x times a plus b plus a, because we have this both a times b minus a. Wait, this a is actually a. Okay. So that's will equal to 0 times x minus 1. Why we get 0? Where do you find 0? So because there is x variable here and there's no x variable here, so we just assume that x must be equal to 0. So that's why we get this equation. Next. So the next step is we try to find the both value of a and b. So we're using some method called elimination. So elimination here, you can read it here. Elimination is solving a system of equations to remove variables. So by using the elimination technique, we cancel out the a. We'll cancel out this a because a plus a mean a plus negative a will cancel out, will equal to 0, right? So here we have 2b is equal to 1. So b will equal to 1 over 2. Because we move this 2 into this. So we will get b is equal to 1 over 2. So we already find the b value. So the next step is we try to find the a value, that's easy. So we're using this equation. So a plus b, which is 1 over 2 here. Oh, that sucks. This is 1 over 2 is equal to b is equal to 0. So that's how we get a is equal to minus 1 over 2. That's how we get a. So you can read it by here. So by using the elimination technique, we cancel out the a so we can get the b value. Since a is equal to 0, then we can find the a's value by inserting b equation into a, so we get a value. So we're gonna move into the next step. Gonna change it. So the next part is the integration part. So here we have this integration, which is integral of 1 over x squared minus 1 squared dx is equal to integral of a over x plus a times b over x minus a. Oh, this one looks like q, but it actually just a. It's a mistyping for me. I'm so sorry again. Dx. Insert the a and b value into the integration, so we get minus 1 over 2a times integral of 1 over a x plus a dx plus 1 over 2a times integral of 1 over a minus x minus a dx. So we're using the integral formula, so we changed a minus 1 into t, so dx will equal to dt, same as here. X plus a is equal to u, so dx will equal to du. So here's what we got. Minus 1 over 2a times integral 1 over t, which is t is equal to x minus a dt, plus 1 over 2a times integral of 1 over u, which is u is equal to x plus a du, is equal to minus 1 over 2a ln t plus 1 over 2a ln u. So here we have 1 over 2a ln t over u. This bracket here is called the absolute value. So that's how we get this equation. 3 times 1 over 2 times 1 ln the absolute value of x minus 1 over x plus 1. We take a as 1, t is equal to x minus a, and u is equal to x plus a. And then we insert all the value above into the equation, so we get this equation. And this is the final answer. So those above are all the reason how we get this integration problem solver by photomath, of course. So from the first step, second step, and then from the final answer, that's how we get it. So that's all I can do to you. I'm so sorry because I'm not good at explaining something. So thanks for watching.